Okay, boys. Today we'll discuss about a new topics for pressure and states of matter. And the topic is buoyancy. The name of the topic is buoyancy. B-U-O-Y-A-N-C-Y, buoyancy. You can say its name in another format as upward thrust. You can also call it as upward thrust. But the definite name of it is buoyancy. The name is buoyancy. Okay. So how we can define this word, how we can explain it. First, we will go for the definition, buoyancy. I am telling you the definition, you just write it. When,
Assalamu alaikum, sir.
Walaikum salam, turn off your microphone. When an object is partially or fully, when an object is partially or fully immersed in water, partially or fully immersed in water. When an object is partially or fully immersed in water, then the upward force acting on the body by acting on that object, then the upward force acting on that object, is called buoyancy. Upward force acting on that object is called buoyancy. So how we can explain it? Suppose it's a container which is filled with liquid or water, you can say anything of it. Generally we use water because water is mostly available in our surroundings, that's why. Okay, so now if we talk about the upward thrust of buoyancy, suppose you are submerged an object. This is the object which is fully immersed under the liquid. Then the object will give it weight, which is acting along the downward direction. But this liquid is trying to get out of this object or remove this object from it. That's why this liquid is giving another force which is opposite to that weight. And that force is U, which is upward thrust. Or you can say it as buoyancy. On your textbook, this upward thrust is written in the form of F. This is called F.
Sir.
F represents buoyancy. And
Sir.
U, here I am denoting the sign U, which is also represents buoyancy, which is upward thrust. So any of you can use the letter U or F. Any of it you can use here. But we will use F here. Okay? So here we can say F as buoyancy.
Sir, is this thing also applicable for gases?
Yes, it is also applicable for gas, but if we consider the gas buoyancy is a very, very small amount. But we can feel the buoyancy when we are in liquid. That's why we discuss it with liquid, but we can also include the gas. We can also include buoyancy in terms of gas. Okay. So how we can describe this thing? Shamsal Kader, is it your class student? Shamsal Kader?
Yes, sir.
Okay. I am including him. Okay, now how we can say buoyancy and weight in the form of mathematical form? If we say weight, we can say W is equal to mg. W is equal to mg, where m is the mass and g is the gravity. So when we submerge or immerse an object into water or liquid, at that time its weight can be considered as mg. But if this object has a volume of V, and if this object has a density of rho, suppose this is its density of rho, then the object mass can be said as m as v rho, where rho is the density of the object. I can also consider it as rho 1. So it is v rho 1. You can say also, because there are two density here, one for the object and another for the liquid. So the object mass m is v rho 1. You can consider it. Now, if I say, so what will be the weight? The weight can be said as v rho 1 g. So you can also say this as v w is equal to v rho 1. This is for. But now, if I say about the buoyancy, if I say what is buoyancy, then we all know that buoyancy is the upward thrust. Buoyancy is the upward thrust, which is acting in the upward direction, or you can say which is acting opposite to that weight. So who gives that buoyancy? Definitely the liquid gives the buoyancy or the upward thrust. So if I say, what will be the buoyancy? If I say the buoyancy is X, it will be V rho 2 G. Just like V rho 1 G, we can say buoyancy as V rho 2 G. The one thing it is changed here, that when we consider the weight, we will consider the density of the object. But when we consider the buoyancy, we consider the density of the liquid. So here, the main difference in these two. One is the density of the object, and another is density of the liquid. So these are the two major difference between these two formulas, W and F. If we consider W, it is V rho 1 G. And if we consider F, it is V rho 2 G. So these are the two things. Okay. So how we can get the result when an object will float, when an object will sink, or we can discuss about this type of concept. So at that time, we have to compare these two, W and F. Okay. So if I say, if W is greater than F, that means weight of the object is greater than its buoyancy, then the liquid cannot bring the object in the upward direction, because it has not such force to go but to move the object in upward direction. That's why the object will sink. The object will sink. And if I say W is smaller than A, so now you can say the weight of the object is smaller than its buoyancy. So buoyancy is greater, weight is smaller. So obviously, at that time, the object will float. Okay. So when the weight of the object is greater than its force, it will sink. When the weight of the object is smaller than its force or buoyancy, it will float. So these are the two main conditions, whether the object will sink or the object will float. Now we go for a math. In this math, we will go for first, we will determine the weight of the object, and after that, we will go for its buoyancy when it is released in some liquid.
Sir.
And then we will compare both of it.
Sir.
And finally, we will get a conclusion whether it will sink or float. Yes.
স্যার একটা মানে মোটা পাথর একটা চিকন পাথরের থেকে মানে ডেনসিটি বেশি না ওই মোটা পাথরের?
মোটা পাথরের ডেনসিটি চিকন পাথরের থেকে
বেশি না?
এগুলো তোকে কে বলছে?
স্যার ওই
স্যার ডিপেন্ড করে না পাথরটা কিসের তৈরি মেইনলি?
হ্যাঁ, obviously a big stone and a small stone have the same density. এটা সেম ডেনসিটি থাকতে পারে, ডিফারেন্ট ডেনসিটি থাকতে পারে, এটার সাথে বিগ আর স্মলের কোনো ফ্যাক্টর নাই।
আচ্ছা স্যার।
আচ্ছা, আমি তোমাকে একটা উদাহরণ দিই, তাহলে তুমি জিনিসটা বুঝতে পারবা। সেটা হচ্ছে the density of wood is 500 kg per meter cube and the water density is 1000 kg per meter cube. wood কিন্তু পানিতে ভাসে, wood float করে ওয়াটারে বা লিকুইডে। এখন একটা গাছ, মনে করো বড় একটা গাছ কেটে ফেলে রাখা হয়েছে, ওইটা 10 জন মানুষও তুলতে পারবে না, এত ভারী। কিন্তু যদি বন্যা আসে ওই গাছ কিন্তু ভেসে চলে যাবে। তাহলে এখন বলো, বন্যা আসলে গাছটা ভেসে চলে গেল কেন? এত ভারী একটা উড যে 10 জনে মিলে তুলতে পারবে না, এত ভারী একটা গাছ। বাট বন্যা আসলে বন্যার পানি ওইটাকে ভাসায় নিয়ে চলে গেছে। Why? Because the density of water is greater than the density of wood. So wood will float on water no matter what will be its mass. তার mass যদি কয়েক টনও হয় তাতেও কিছু যায় আসে না। The wood will float on water. So এখানে big object or small object, it doesn't matter. The matter is density. Whether the density is greater than liquid or the density is smaller than liquid. So you have to determine these things first, whether its density is greater or not. Okay. So first we will go for a math. We will use these two equations. You can use W is equal to V rho 1 G or W is equal to mg.
Sir, I have a question.
Anything. Okay, I give you time and you will go for buoyancy with this equation. Okay, now what do you want to ask?
Sir, in case of flotation or when submerged, does the surface area matter? Because we see ships floating which are of very heavy mass.
I can't hear you properly. Some part of it I hear, and the total sentence I cannot make it. And
hello.
What you ask actually?
Sir, does the surface area matter? Because we see the ships which float in the sea and they are of high mass, so they float. But so how do the surface area overcome the buoyancy force or the weight here?
Okay, so here the surface area, when suppose a blade when you use to shave the blade, if you talk about the blade, আমরা এখন এইসব ব্লেড ইউজ করি না, আমরা ওয়ান টাইম রেজার ইউজ করি। বাট ওই ব্লেডটা যদি তুমি হরিজন্টালি ওয়াটারে রাখো, at that time the blade has much surface area, so the upward thrust will be greater than its weight, so the blade will float. The blade has density more than water because the blade is made of steel and steel has density of 7,000 kg per meter cube. But according to its surface area, when you place the blade horizontally in water, at that time the upward thrust is greater than its weight. That's why the blade, though its density is greater, due to its surface area and its buoyancy, it will float. But if you place the blade vertically, then you can find that the blade will sink. Because at that time, it has a surface area very, very small, which the water or liquid cannot give the proper buoyancy on it. That's why the blade will sink. So density is a fact, but surface area is also a factor here. If I make the surface area very wide or I make the big surface area, then maybe the object has more denser than the liquid, but it can float. Such as the ship is floating in water, or we can say any kinds of metal surface can be floated in water, though it has greater density. But the main factor is when I am considering the shade, I am here considering a sphere. You can see I can make a sphere here. So according to this sphere, the density is the main factor. Well, if the density of the sphere is greater than liquid, it will sink. If the density of the sphere is smaller than the liquid, it will float. So we are talking about a sphere here. Because when I give you the information, I will talk first the spherical form. After that, I will go for another formation. Okay. Now we will go for one math. One math, and the math is like this. A sphere has radius of 5 centimeters. A sphere has radius of 5 centimeters. And its mass is 200 grams. And its mass is 200 grams. Give full stop.
Sir, radius ta কত?
Radius হলো 5 centimeter and its mass is 200 grams. Now give full stop and now go for Roman 1 and Roman 2. Roman 1, what is the weight of the sphere? And Roman 2, what is the buoyancy of the sphere? So these are the two information you have to get in answer. 1, what is the weight of the sphere? And 2, what is the buoyancy of the sphere if it is released in water? Add this part also. What will be the buoyancy of the sphere if it is released in water? You have to write this whole sentence. If it is released in water. Okay, so first, here I am giving you another information which is not included at the math yet. The density of the sphere. Oh no, you have to first get the density of the sphere because I am giving you the mass as well as the volume. I'm not giving you volume in terms of cc, but I am giving you like this. V can be said as 4/3 pi r cube. So from this point of view, you can get the density of the sphere. But you are not asked to get the density first. You are asked to get the weight first. So how you can get weight? It's an easy one because W is equal to mg. You are given M as 200 grams. So it's 0.2 kg and you know the value of G. So first you will get the
Buoyancy
value
is
of W.
5.13 Newton.
What will be the value of W? You get the first W value. What is the value of W?
Sir, 1.96
2.
Newton.
Okay. So it's 1.96 Newton. Okay, this is the first one. Okay, and what you tell about the answer of buoyancy?
Sir, 5.13 Newton.
Okay, so it's V rho 2G, the right one. And what is V here? It's 4/3 pi r cube. Then you are adding with multiplying with rho 2 and G. And you will get 5.96
5.131 Newton.
5.131 Newton. So it's more than its weight. 5.131 Newton. If I say the result is buoyancy is 5.131 Newton, it is much more than its weight. So obviously that object will float. The object will float. But I'm not asking you in the question, will the object float or sink? But we can understand. You have to go for meter. You have to. Otherwise, the answer will not be perfect. So this is the first concept where we have got that if W is smaller than F, that means the buoyancy has the greater value than its weight, then the object will float. So this is the first part. Okay. Now we will use another question. Okay.
Sir, if the buoyancy is equal to the weight, sir, then will there be a 50-50 floating and immersed in water?
No, it's not the 50-50. It's actually, it will float, but under that liquid. It will float by submerged fully on the liquid.
Like, sir, the top part of the body will touch the upper layer of the water, of the liquid. Something like this.
No top part. No top part. The whole part, just like that. If I say, if this sphere has the upward thrust and its weight is equal to each other, say, then this sphere will float under the liquid, but it will submerge fully on it. It will submerge fully on it, but it will not reach at the end of the liquid. It will float in the middle section of the liquid. It will not go to the upward direction or in the downward direction. It's just floating in the middle of it. If W and F are equal.
Sir.
Yes.
Sir, here we see that the whole body is not immersed. Rather, one part is floating and another part is sink. But why the buoyancy force is applied on the total volume?
The buoyancy is applied on the total volume. Here we can say, because we are using the total, we are say that it's a sphere volume. It's a sphere volume. That's why we consider its total sphere volume. আমরা এখানে এর জন্য ইউজ করছি। But actually কিন্তু buoyancy-টা যতটুকু ডুবে অতটুকুর উপরে কিন্তু কাজ করে।
Yes sir.
নিয়ম কিন্তু তাই। buoyancy-টা যতটুকু ডুবে অতটুকুর উপরেই কাজ করে। এইটা হলো আমাদের একটা ফ্যাক্টর যেটা দিয়ে আমরা আইডেন্টিফাই করি যে এটা কতটুকু ডুবছে আর কতটুকু ভাসছে সেটা না। এটা দিয়ে আইডেন্টিফাই করি এটা ডুবে না ভাসে। কতটুকু ডুবতেছে আর কতটুকু ভাসতেছে সেটার জন্য আইডেন্টিফিকেশনের জন্য আমাদের মানে আরেকটা ইকুয়েশন আছে, আরেকটা কনসেপ্ট আছে। এখন মনে করো জিনিসটা হচ্ছে অনেকটা এরকম, সাপোজ ইউ আর ইন এ সুইমিং পুল and you are half of the water, your body is half on it. So actually at that time the buoyancy is only on your half of body which is underwater, and the rest of your body the buoyancy is not applying the force on it. But if the buoyancy has that ability that half of your body it can float the half of your body, then the body which is above the water that will be also affected on it. যেমন তুমি জাহাজের কথা চিন্তা করো, জাহাজের কিন্তু পানির নিচে কিছু অংশ ডুবে থাকে। জাহাজে if we talk about this, if I say it's a ship just like this, suppose it's a ship and the ship is quite an area is underwater. So if I say this is the underwater ship, কিছুটা কিন্তু পানির নিচে সব সময় ডুবে থাকে।
কত পার্সেন্টেজ ডুবে থাকে?
But if the weight of the ship is still less than its buoyancy, the ship will not sink, the ship will float. So at that time the rest of the part which is above the water height also affected by the buoyancy. This is the reason.
Okay, sir.
That's why we included the whole volume of it.
Sir, if it comes in our exam directly, what is the buoyancy force? Then what will you use, the total or the immersed part only?
That's why you are saying that partially or fully. You are saying that before on your definition that if an object is partially or fully submerged or immersed in water, then the upward thrust on this object is called its buoyancy. So no matter what, if it is partially or fully submerged, the upward force acting upon it is buoyancy. Buoyancy is not a fixed value. Buoyancy is changed. If you load more, if you give more load on this ship, the ship will sink more. And at that time, the buoyancy is slightly changed. So buoyancy is a changing factor. Buoyancy is not a fixed one. So you can consider it, it's a changeable thing. It's not a constant, it's a variable thing. So the definition will give you every information. When an object is partially or fully submerged in a liquid, then the upward thrust of the object is buoyancy, whether it is half submerged or fully submerged. That the upward thrust is buoyancy. Okay.
Thank you, sir.
So we will go for another map. Now I am giving you another thing. Floating and drowning part. Floating and drowning part of an object. We will discuss now how much of an object will float and what will be the fraction of an object that will sink, and that can be derived by an equation which is like this. Density of object is equal to drawn part of the object into liquid density. So if we talk about how much of an object will float, how much of an object will sink, then we will use this equation. Density of an object is equal to drawn part of the object and liquid into liquid density. This is not directly given on your textbook, but it gives us an information which comes from a topic which is also related to this buoyancy. It is called the specific gravity, but this topic is not included on your textbook. The previous textbook, the topic was there out there, but we are using this because when we are doing some buoyancy math, this equation will be needful. So if I say the density of an object, I can say it's a rho. The drawn part, you can say the drawn part, just like this. And the density of the liquid, you can say it's rho F or rho L. F, why we use F? Because F is fluid. That's why we use F. Okay. So this is the equation. And using this equation, we can say that whether an object, how many part of it will float and how many part of it will sink. Okay. So first we will go for ice. Just consider ice. We know that if I release an ice cube in water, if I release an ice cube in water, the ice cube is just like this. It will float, but drawn maximum part of it. Its maximum part of it will drawn under the water. Minimum part of it will be above the water. And if you give the partition, then you can say that 1/12 part is above the water and 11/12 part is under the water. So from this fraction, I can get the density of ice also by using the above equation. So what will be the density of ice if I use this equation? The density of ice, rho I, is drawn part is 11 by 12. And the liquid density, I'm releasing it in water, so it's 1000. If I multiply these things, I can get the density of ice. What will be the value of it?
916 in 0.67.
916.67
6.67
kg per meter cube. So if I get a density, I can also derive how much of the object drawn under the liquid, or if I get the drawing part of it, I can get its density by using this object
Sir, I have a
equation.
question, sir.
Okay.
Sir,
What
why
is
is
the
the
question?
density of ice lesser than the density of liquid water? In solid, it shouldn't it be more than the liquid state?
Actually, we know this one thing, that when we consider the solid and liquid, solid has more dense than the liquid state. The density of liquid is less than the density of solid for any object. But for ice, it's an exceptional thing, because if we consider the 4 degrees Celsius water, it has the most density. If we consider the 4 degrees Celsius water, it has the most density. And after that, 4 degrees Celsius water has most density. And after that, if we go for 3 degrees Celsius water, less than the previous one, less than the previous one, 2 degrees Celsius, less than the previous one. So when we talk about 0 degrees Celsius, less than the previous one. So it will decrease. This is an exceptional thing. If we decrease temperature of any material or any substance from liquid to solid state, then at that time its density is increased. But water has an exceptional thing. Its density will be decreased when we go from water to ice section. And then the ice will have the density which is smaller than water. And that's why ice floats on water, though it is solid, but it floats on water. This is an exceptional thing. This is not the general concept, not like that. Okay. So, do you have any question?
No,
Sir,
sir.
why it happens in case of water?
Why?
Sir, why it happens in case of water?
Actually, it is an exceptional thing. You can say that it's a creation of God. Exceptional thing.
Sir, is it because of the intermolecular?
You have to remember one thing, that exceptional is not a general example. The general thing and the exceptional thing is totally different. The water has this ability, or onno kono liquid ability নাই, just water ability.
Sir, does the anomalous expansion does not happen in any other liquid?
Structural problem. Huh?
That does this anomalous expansion occur in any other liquid?
Any other liquid এই ধরনের এই ওয়াটারের মতো থাকবে কিনা, কোনো চেঞ্জ আসবে কিনা?
জি জি।
এটা What is the question?
Yes sir, এটা।
Now, only water is the only one liquid. Water is the only one liquid which gives us this exceptional thing, that when you decrease its temperature less than 4 degrees, then its density is also decreased. But other liquids, when you decrease its temperature, its density increases. So water is definitely an exceptional after 4 degrees Celsius when you are decreasing its temperature. Its density is decreased. Okay. So boys, we will close for now today, and again we will come for the next class and the next part of it. We will go for some important maths for buoyancy. Also, we will do some combined object buoyancy math. Those are very important for creative questions. So I'm stop this class right now. We will come back to the next class and we will go for the next topic. Okay, thank you, boys.
Assalamualaikum, sir.
Now,
Assalamualaikum, sir.
stay safe. Walaikum salam. Allah Hafiz.
Assalamualaikum, sir.
Salam.
Assalamualaikum, sir.